A business operates a web-based search application utilizing CloudFront, ALBs, and EC2 instances in an autoscaling group with a desired capacity of 3. The application uses pre-baked AMIs and takes 1 minute to initialize, communicating with an Amazon OpenSearch service cluster. Due to regulatory requirements, a disaster recovery site is required in a separate AWS region. The organization must ensure an RTO and RPO of under 30 minutes while keeping DR costs at a minimum. An ALB has already been deployed in the target DR region.
Which approach satisfies these conditions? Option A, add the DR ALB as a secondary origin in the CloudFront distribution with failover enabled. Transfer the AMI to the DR region, configure an auto-scaling group with a desired capacity of 0, and implement cross-cluster replication for a new OpenSearch cluster. Option B, establish a separate CloudFront distribution using the new ALB. Utilize Route 53 for failover, transfer the AMI, set ASG capacity to 0, and use OpenSearch multi-AZ deployment.
Option C, establish a separate CloudFront distribution using the new ALB, utilize Route 53 for failover, transfer the AMI, set ASG capacity to 3, and use OpenSearch multi-AZ deployment. Option D, add the DR ALB as a secondary origin in the CloudFront distribution with failover enabled, transfer the AMI, configure an autoscaling group with a desired capacity of 3, and implement cross-cluster replication for a new OpenSearch cluster.
Let's consider the core concepts here. The goal is disaster recovery with specific constraints, RTO and RPO under 30 minutes, while prioritizing cost optimization. We are looking at a system with CloudFront, compute resources that take time to boot, and data synchronization across regions. The strategy needs to balance immediate availability with the ongoing expense of maintaining idle resources in a secondary location.
In my view, the correct answer is option A. To minimize ongoing costs while meeting a 30-minute RTO and RPO, a pilot-light DR strategy is the most effective approach. Configuring the CloudFront distribution with origin failover allows for seamless traffic redirection to the DR region if the primary region becomes unavailable. An auto-scaling group with a desired capacity of 0 in the DR region minimizes costs. When disaster strikes, the capacity can be increased to 3.
With a 1-minute application startup time, this approach easily meets the 30-minute RTO requirement. Furthermore, Amazon OpenSearch Service cross-cluster replication is the standard AWS solution for synchronizing data across regions to ensure a low RPO. Regarding the other options, option D is incorrect because it specifies a desired capacity of 3, which fails the requirement to minimize ongoing costs. Options B and C are incorrect because they use Route 53 DNS failover, which is less efficient.
Additionally, options B and C incorrectly apply OpenSearch multi-AZ deployment concepts to a cross-region scenario. When evaluating DR strategies, always check if your chosen solution prioritizes cost while still meeting your time-based recovery objectives. Look closely at the capacity settings in your auto-scaling groups and ensure your data synchronization method aligns with your RPO goals. This combination of CloudFront failover and cross-cluster replication provides a robust solution.